That question is question number 76. The most acidic compound among the following is. We have all the phenol derivatives here. We know that phenol is more acidic as compared to alcohol, and the acidic nature of phenol is increased if some minus M effect or negative I effect group is attached to it at para position. If you look at NO2, this is minus I group. It has electron withdrawing nature. So as showing its acidic nature, phenol will lose its H plus ion, and after losing that it will form phenoxide ion that can be represented here in this way. This is the phenoxide ion of this nitrophenol. Now this negative charge is stabilized by this NO2 because this is electron withdrawing group. It stabilizes this phenoxide ion and make it more acidic. While if I talk about option 3, here methyl group is there, that is electron releasing group, that will not increase its acidic nature. Similarly, if I talk about OCH3 methoxy group is there, that is also not doing so. So most acidic among these is nitrophenol, para-nitrophenol simply, and that's why the answer for this question becomes option 2. Question number 77. Which of the following ion or the ions are present as an active ingredient in bleaching powder? Bleaching powder, CaOCl2, calcium oxychloride we are taking for bleaching action. If we talk about bleaching powder, in that case this OCl negative is the active ingredient that is the main cause of bleaching action. Why? Because it has the nature to release nascent oxygen. How it happens? Actually in water it forms HOCl. Along with that, OH minus ions are released. It means this OCl negative is acting here as proton acceptor. Now, this HOCl gets changed into HCl because this HOCl is highly transient species. So, active oxygen, nascent oxygen is released here. This nascent oxygen is the main cause of the bleaching action. When it comes in contact with the colored substance, it decolorize it and make it bleached substance. So, which is the active ingredient in this case? That is given here in option 3. So, just choose option 3 as your correct answer. After this, question number 78. Which of the following is isostructural with diamond? If I talk about diamond, diamond has sp3 hybridized carbon. Its shape is tetrahedral, we know that. And if I talk about solid H3BO3, this H3BO3 has hexagonal structure, not the tetrahedral. Further, boron nitride. Boron nitride has graphite-like structure. sp2 hybridization is there. That's why it is not the correct one. Carborundum, silicon carbide. Yes, it has sp3 hybridization. Its structure is considered as diamond-like structure. While borazine is the inorganic benzene, and in this case also sp3 hybridization is not there. It is not isostructural with diamond. So only one correct option we have, that is option 3. So choose it as the correct one. Question number 79. General formula unit of cyclic silicate is. We have different formula units are given. We need to just find out the general formula unit for cyclic silicate. If I talk about SiO2 negative, this is not the cyclic one. Further, Si2O76 negative, this is the general formula for the pyrosilicate. And here is SiO3 2 negative N. Yes, it is the formula for the cyclic silicate, while the option 4 consists of the general formula unit for the sheet-like silicate, sheet silicate simply. So, option 3 becomes the correct option. Question number 80. Hyperconjugation is absent in. What is the necessary condition for the hyperconjugation? That is the presence of alpha hydrogen. It means hydrogen atom at alpha carbon should be there. That can show the hyperconjugation. So simply if I talk about the first option, this is a free radical. Radical is present on this carbon atom. Alpha to this is the carbon. And at this carbon there is alpha hydrogen. That's why it will show hyperconjugation. The second option we have, this is the carbon at which this electron is present. This is free radical basically. Alpha to this two carbon atom. This carbon as well as this carbon. And at this carbon, if you focus, there are two methyl groups. There is no alpha hydrogen. Similarly, at this alpha position, there is no hydrogen atom. Two methyl groups are present and these two are bonded here. It means there is no hydrogen atom. So in this case, hyperconjugation is not possible. Why? Because due to the absence of alpha hydrogen, we know that. Further, if I talk about the third option, this is the free radical, and alpha to this carbon is here, this carbon is here, and both of them consist of alpha hydrogen. Hyperconjugation is possible here. Simply in this case, this is alpha, and at this place alpha hydrogen is there. Similarly, here also alpha hydrogen is present, and this will also show hyperconjugation. And now the correct answer would become option 2, in which alpha to the free radical there is no alpha hydrogen.